Yeah, good morning, students. So I am Disha Roshan Bhakta, Assistant Professor, Department of Information Technology, Bansanga Shiti College of Science, Commerce and Management Studies, Powai. So students, today we are going to see about agent types, and with the examples of those agent types, we are again going to see about PEAS, which we do have already covered into our previous session, but there will be again a quick, we can say, recap of PEAS. And then in our previous session, we also had looked upon the different types of environment, okay, and how different types of environment works differently with the different agent types. So over here, we are also going to see with examples of agent types, those environments, and yes, that will be quick, we can say a quick recap of all those environment types also again, okay. So yes, our today's discussion will revolve around PEAS and their examples, and again nature of environment and the various agent examples with related to that. Okay. At the end of the session, okay, I would be giving you certain more agent types, and you have to find out what would be the PEAS and the nature of environment for them. Okay. Of course, you can take your time, and after that, you can find out, and then yeah, we can discuss about that those things into our next session. Fine. Okay. Yeah, so let's go ahead. Okay. So I think, yeah, we are already aware of about what it's PES. Okay. So first, quick recall of what we call it as agent. As agent is nothing but, okay, someone who is in continuous interaction with the environment, who has sensors, actuators, okay, that there is a percept which agent receives from the environment, and then depending on the percept, a certain set of actions is taken. There are many agents which also remember the percept sequence, that is nothing but we call as the history of inputs that the agent has received. Okay, and yes, in the process of understanding agent, we have also understand what do we call about rational agents. Okay, what do we mean about the concept of rationality, and then finally, okay, when it comes to the start of making an agent, to understand what is the PEAS of agent is very important. Okay, so PEAS is nothing but we call it as performance measure, environment, actuators and sensors. Okay, what is the performance measure of the agent? Okay, for what purpose actually you have developed the agent, and whether the agent is working according to the purpose or not. Okay, so yeah, that is the main thing. Okay, that's what is we are trying to tell over here. Okay, and then yes, environment, I think we all are aware of. Okay, what do we mean by the environment, right? Okay, we also have discussed many types of environment features also. Okay, then actuators, okay, they are nothing but the things, okay, which are going to help to let's say throw output to the environment. And sensors, they are nothing but certain devices which are going to help us to take input from the environment. So yeah, that was about PEAS. Okay, fine. Going forward, the very first agent type, okay, that we're going to discuss for PEAS is taxi driver agent. Okay, what is the performance measure? So there could be several performance measures, okay, and it solely depends upon what was the need to make this. Okay, what was the purpose? Was the purpose for let's say a safe trip for the passenger? Was the purpose a fast trip for the passengers, like that? But the thing is that could be also multiple performance measures for an agent. And yes, there is also priority on which performance measure is of more important when it comes to the working of agent. So if we talk about taxi driver agent, okay, the performance measure are safe, fast, legal, comfortable trip, and maximize profits. Okay, so these are the performance measures. Okay, so let's say if a taxi driver agent is working in an environment, and if these all measures are followed, okay, then it is known as that the agent has worked according to the need of for what purpose it was basically created. Okay, Now let's say the priority of safe and fast is like safe is more important. Okay, and fast is next prior to this. So this is how also. So let's say at times, let's say the taxi driver agent has reached to more time than what was expected, but the entire journey was safe. Then it is absolutely fine, because that is our more prior performance measure. Okay, and maybe the vice versa will not become true. So that's what about performance measure is. Okay, environment. So the environment for these type of agent will be roads, traffic, and pedestrians walking on the road. What would be the sensors? Let me discuss sensors first, because that's using that the agent is going to take the input. The sensors for the agent will be cameras, the GPS systems installed into that taxi, then let's say engine sensors, speedometer, etc. And what are going to be the actuators? So the actuators are going to be steering, accelerator, brake, signal, horn, etc. Okay, so these are going to be the accelerators, and using all these things, okay, the agent going to do its work or perform its work uh, into the environment, and then it's going to have its performance measure to, let's say, have the passenger's journey from location A to location B. Okay, yeah. So this was about the first type of agent. Okay, moving forward, next is medical diagnosis system. Okay, now what is medical diagnosis system? Okay, so we are already aware of students that, okay, it's nothing but a system, which is going to continuously probably, ask the patients about what things they are facing, and then reply the patients according to their symptoms or something like that. Okay, so what is the performance measure of this system? Okay, so maybe, after a continuous set of interactions, it should happen that the patient should be healthy, the patient should feel much better than what the patient was feeling before. Okay, there should be reduced cost. Okay, a reduced cost in the sense, let's say, the whole process of the diagnosis should be, cost effective for the patient. So that is the performance measure. What is the environment? Now environment over here, so let's say it is also possible that this system can be individually just, handled by a patient. In that case, the environment will be patient. At times these kind of systems are also installed in big hospitals, or at places where the number of patients are quite high. Then in that case, these systems at the initial level help the patients to decide, and even help the hospital to diversify the patients according to their requirements. So rather than the patient, waits for a certain amount of time, and then it comes to know that, okay, he has to, visit this doctor, or this is something what he's facing, because it might happen that the patient is not clear about its own symptoms also. So that whole process will take lot amount of time, even if that is a case of hospital. So there are hospitals which have installed these kind of systems, and yes, that's why the environment can be hospital and the staff of hospital also. Okay, what are the sensors? Okay, so the sensors are going to be patient answers for the questions which is going to be given by these medical diagnosis system. And of course, patient can select a set of symptoms which the patient is feeling right now. So, there can be well defined GUIs, that is graphical user interfaces, wherein the patients can feed their symptoms, or, can also tell to what level it is. So let's say if the symptom is about fever, then there could be a scale on what level it is, whether it's very high or low or mediate or like that. Okay, and then depending on that, this system can throw certain output. It can ask certain few more questions uh, to the patient. It can tell about that these kind of tests are maybe required, that you should perform, you should go under these kind of diagnosis, okay, or these kind of treatments. Of course, these kind of system can also help the patient to redirect to a particular doctor of, let's say, a particular specialization. Yes, so these are the basically, expectations when we talk about a medical diagnosis agent type. Okay, yeah. Going forward, yes, part picking robot. Okay, so when we say an agent type part picking robot, then these robot has variety of applications. So it could be like maybe just differentiating the parts according to the sizes, as in if there are multiple parts coming, okay, then the smaller part, okay, just an example, let's say if there are multiple boxes, packaging boxes which are coming, then maybe the smaller boxes should be picked up and placed to a different place. Then the average size box should be picked up and placed to different place. Then maybe the bigger size boxes should be taken and placed to a different place. Also it might also happen that certain parts are going, and if there are certain defective parts, then need to be picked up. So there could be variety of applications, and depending on what exactly was your purpose of making this part picking robot, your performance measure will be there. So let's say performance measure, let's say one of the performance measure could be the percentage of parts in correct place. Okay, so percentage of parts picked up, and let's say put it into the correct place. What will be the environment? Okay, so there will be a conveyor belt. Okay, similar, maybe if you have seen on airports where the luggages, there is a belt and on which the luggages are going. So similarly the conveyor belt will be there, and on the part on that conveyor belt, multiple parts will be going on. Sensors would be, so when these parts are going on, okay, the part picking robot will just sense, or using the camera and certain sensors, that oh, okay, fine, this is the part which need to be picked up, and then the actuators will be a joint arm and a hand which will really just pick up that part and put it somewhere. Okay, so that's about part picking robot. Yeah, interactive English tutor. Okay, so again, a famous agent type. So this is one example of English tutor. Of course, there could be multiple interactive tutors with respect to certain things. Yeah, but this is something very famous because uh, this is a this could be a requirement to, which exists at times at a global level also. So now, what will be the performance measure? So over here, the performance measure could be the student score. Okay, or it also may be, let's say, before using this agent, okay, what was the proficiency of the student in English. Okay, so let's say the student has given certain input. Let's say that the student is very low in English proficiency. Okay, and then the student starts using these agent, and then maybe after 1 month it is asked again, then what is the proficiency now? Okay, and let's say the proficiency from low level increases to, let's say, level 1 or level 2. In that case, that will also become a performance measure for this tutor. What is the environment? Set of students, if the students are using individually. At times many testing agencies are also there who install these kind of systems. Okay, what will be the sensors? So the students will ask continuous questions by voice or by keyboard entries, and then the output will be certain reply to the questions which are asked by student. Okay, then certain corrections of grammar and other things which the system will do when the students are saying something. Okay, and certain exercise will be given to the students which they have to get completed. So this is how the interactive English tutor is going to work. Okay, so yes students, these were certain examples of agent types and their PES, but there could be many different agent types which we can take, and it should become now understandable to us that how we can find out their PEAS. Okay, at the end of the session we are going to take one or two examples, and then we are going to understand how PEAS of them could be found. Okay, now going forward, okay, now what we are going to discuss is that, so okay, we already understood what is PEAS. Now we are going to focus on environment. Now why environment is going to become very important? The reason is that until and unless the agent is not very clear with the scenario of the environment, okay, the agent will not be able to understand how it should work, because it has to continuously interact with the environment. So it should know what are the characteristics of my environment in which I'm working. Okay, and that's where come the different types of task environment. So first of all, before we go into the example, let's first of all have a quick discussion of the exam of the task environments which we have already gone through. So the first kind of task environment was fully observable, versus partially observable, where we understood that if the agent could understand each and every aspect of the environment, if the agent could sense each and every aspect of the environment, then it goes into fully observable environment mode, else it can result into partially observable. Then we saw about a concept of single agent versus multiple agent, wherein single agent, there is only that agent, and that agent is playing into that scenario, or let's say working individually into that scenario, wherein in the concept of multiple agent, there could be multiple agents, okay, including one agent as a human agent also. So yes, that could be the scenario. Then we saw that if it is multiple agent, then multiple agent could also further get categorized into cooperative multiple agent and competitive multiple agent, okay. Then we saw about something known as deterministic and stochastic. So if things are well known, if the environment gives only fixed kind of inputs, then it will be deterministic. If the environment starts throwing random inputs, then it will go into stochastic. Afterward, we saw episodic and sequential. Now what do we mean by episodic? So let's say in episodic environment, only your current percept is important, okay, history of percept is not important. Whereas when we talk about sequential environment, the current percept and the history of percept both are important for taking your next action. Okay, then we saw something known as static and dynamic. Okay, so the environment will be static if the number of steps or maybe the number of percepts and everything will be well defined, and it is not going to grow. Okay, those things are mostly going to be fixed. And when we talk about discrete versus continuous, again we are telling that when we talk about discrete, the states for the agent, okay, that will be fixed, which means the agent will be well aware about what kind of different states the agent will be facing. And thereby, if there is a combination of static and discrete, it becomes very easy for the agent to just map the percept to output. Whereas if the environment is dynamic and continuous, in that case the agent has to continuously learn about the environment. Fine. So yes, students, these were the different types of environment. Okay, now we'll take one example and then we'll try to relate. Okay, that when we talk about these agent type, okay, what will be the environment, and then again we'll recall what was the content of this environment, what this environment wants to say. So the very first example, okay, is the agent type crossword puzzle, an agent which is solving a crossword puzzle. So what will be the characteristics of environment for these agents? So the environment will be fully observable to the agent, okay. The environment is going to be single agent, okay. And because it's not multiple agent, there is no case of competitive or cooperative. The environment will be quite deterministic for the agent, okay. Everything is there which is determined. Sequential, okay, which means even the previous percepts, okay, means history of percept which the agent is going to have is very important. Yes, because let's say if a crossword puzzle needs to be solved, and a puzzle and let's say there is a 5 word over there, then yes, it is very important, okay, what was the previous two alphabets to maybe think, or maybe guess about the third alphabet which is going to be at the place. Yes, so it is quite understandable that only the current percept is not important, history of percepts is important. It is static, okay, static in the sense, okay, the scenario, or we can say the place where it is going to be, it's going to play its role, it's fixed and it's not going to grow. It is not that today certain things will be there and tomorrow it might change. No, it will not be like that, and it will be discrete. Whatever states for the crossword puzzle are there, they will be finite, okay. It can be more, okay, depending on to the size of the crossword puzzle it can grow, but yes, every time they will be finite, they will never go into an infinite mode. Yes, so that was the very first agent type example, okay. Yeah, going forward, student, the next agent type will be chess with clock, okay. Now when you say chess with clock, which means you are here time constraint is being put, okay. And when we don't put the time constraint, then it will be simply playing chess, and when time constraint is not there, at times it may also happen that the whole process of uh, playing it, or let's say the whole process of executing it, may take a lot amount of time, and that's why certain restrictions are put into this agent type. But yes, on the other case, if that is not there, then even the agent type chess can also work on its own. Okay. Yeah, so fully observable. Okay. The chessboard, I think that's the environment, and that's very, very, very clear to the agent. Okay. Multi-agent. Okay. It is not a single agent, it is multi-agent, where the opponent one can be a software agent also and can be a human agent also. Okay. Find deterministic. There is nothing randomness which is going to be thrown from the environment. Everything is determined. Okay. Yeah, the number of percepts could be very high. Okay. But yes, they can be still determined. Sequential, your history of percept is going to be very important. Okay. Static or semi-static, why? Because we have taken clock as parameter, so we cannot say that it will be static only. Okay. And discrete, whatever states of execution are there, that will be finite, they will not go into infinite mode. Okay. So yes, this was the next agent type, that is chess with clock. Okay. Yeah, going forward, the next game is poker. Okay, I think you will be well aware about this game. So the environment will be partially observable over here, and because something is partially observable, okay, it will be not completely determined, and that's why it is also going into the stochastic mode. Partially observable, multi-agent. Why multi-agent? Because of course multiple players, and yes, it could go into the competitive mode also. Stochastic, which means certain, maybe the randomness from the environment can be there. Okay. Sequential, previous percepts are going to play importance. Okay. Static and discrete, which means the states and let's say the percept and actions will be fixed. They will not go into an infinite mode. Okay. Backgammon, again, it is a very famous game. Okay, the environment is fully observable over here. It is working in a multi-agent environment, but yes, certain kind of randomness can be thrown depending on to the player on the opponent side. Then it is sequential. Your previous percept will matter, and it is static and discrete. Okay, which means the environment will have finite number of states, and it will be very clear on what percept certain actions has to be taken. So yes, that was about the next task environment, that is backgammon. Okay. Taxi driving agent. Okay, fine. So I think we are very clear, but this is very different from the examples that we have seen till now. Okay. The environment will be partially observable in the sense that yes, of course, it can understand the pedestrians, it can understand the other agents moving on the road, traffic signals, but at times, let's say the weather is not supportive and there is, let's say, lots of fogginess into the weather or certain more things, then it may go into the partially observable mode. Okay. Of course, also, uh, it is not at all possible that each and everything which is going to come on the roads can be observed. Okay. Because uh, and that's why if you see, it is continuous, which means, okay, the states are not finite. The percepts are not fixed for these kind of taxi driving agent. Okay. The percepts may drastically change depending on which different locations this taxi driving agent is going to move. Okay. Because so in that case we can say that the percepts can go into infinite mode also, because nothing is fixed. Okay. And that's why we see that it is dynamic and continuous. Okay. It is multi-agent. Yes, it is very clear that what is the reason why it is multi-agent. Okay. So the reason is that multiple agents would be there, but yes, this is a scenario of cooperative multiple agent. Why? Because they are not in competitive mode, and they has to take care of the other agents also, while having their own performance measure. Okay. Because their performance measure is safety, and they have to take care about their self as well as the other agents also. Okay. It is stochastic, the environment can throw certain randomness. And sequential, which means whatever previous percept or whatever the previous thing that taxi driving agent has done, it is going to help to take the current action also. Yeah, so this is the environment we can type for the taxi driving agent. Fine. Moving forward, medical diagnosis, again partially observable. Yeah, but it is single agent. Stochastic, many kind of randomness will be there, because there could be n number of patients with n number of different types of feelings or maybe symptoms, and that can never be fixed, that okay, these are the only possible percepts which can be received. No, so that's why it will go into stochastic mode. And that's why if you see, it is also dynamic and continuous. The states can never be fixed for medical diagnosis system. Okay, see, as compared to a game like chess or whatever, the states are fixed. That there can be nothing except this which can happen. Though in that case, the number of states will be very high. Okay, they may go up to a count of 1 lakh also. Okay, which means, but then it is still fixed. Okay, that something will happen from this. Okay, nothing outside from this is going to happen. But in systems like taxi driving agent or medical diagnosis agent, that is not the case. Okay, the agent can never be aware of what could be the possible percepts. Okay, it may not be the case, and the percepts will continuously increase. There is nothing finite. So these kind of systems, basically the taxi driving agent or the medical diagnosis system, or probably all those systems which are dynamic and continuous in nature, in that case they have to continuously learn themselves. Okay, so there will be not very simple thing in this system that you have just a percept, match with action, take the action. So where the environment is static, this can be possible, that percept will be listed down. Okay, if this is the input, what has to be done? Or it will also happen that a sequence of percept will be there. Okay, if you have got this input, okay, take this action. But that cannot be the case when something is which is dynamic. Okay, in that you have to learn, there are certain number of additional things which need to be applied when these kind of systems have to be studied and understood. So yes, that was the next system, that is medical diagnosis. Okay, image analysis, fine. So students, when we have seen about the applications of artificial intelligence, in that we have learn about vision systems. Okay, and if you remember, then we have learned about, we can have an analysis of the satellite images. Then certain forensic artists can also use this to understand the image of the criminal with the database. So that is nothing but we can say application of image analysis, right? Now when we talk about image analysis, okay, the environment is no doubt observable. Why? Because that's the image, and depending on that image, you have to work. So the image is, because the image is already provided to the image analysis system, it is quite observable. Okay, single agent, it has to work on its own. Okay, very determined. Okay, episodic. Now the first example of episodic comes over here. Now what do we mean by episodic is that whenever the image analysis has to be done, okay, it has to be individual for every image. So if a certain analysis of first image is coming out, then it has no relevance to the second image. They both have to work independently. So the percepts of first image are not at all going to have any effect on the percepts of the second image which is coming. So when that kind of behavior is there, okay, then it is known as episodic. Okay, it will be static or semi-dynamic into the nature, depending on how complex that image is. Okay, and it will be continuous, because again nothing is fixed over here. Variety of images could be received. So in that case, the states of these agent type can continuously increase. Okay, we cannot say that every image will have only these 10 characteristics and that need to be identified. That cannot be the case. Okay, so that was about image analysis. Next is part picking robot. Okay, again part picking robot, partially observable, single agent. Okay, and stochastic. Okay, stochastic in the sense, at times it may also happen that certain parts are received onto the conveyor belt and the agent is not trained for that. Episodic. Okay, the agent has to just take care about the current part which is going on. Okay, and dynamic and continuous, because let's say lakhs and lakhs of parts will be moving, and it might happen that certain parts are there now for which the agent is not trained, and that's why this whole process will become dynamic and continuous in nature. Okay, interactive English tutor. Okay, partially observable, multi-agent, because the another agent which is going to play the role will be the student. Okay, stochastic. Okay, because we are not aware about what kind of questions are going to be asked by the students, or what kind of expectations will be there from the students and how they're going to interact, it will go into stochastic mode. sequential. Okay, there will be always previous percepts which will be important. Okay, okay, so talking with the student, what he has told previously is going to be very important. Okay, it will be dynamic in nature and discrete. Okay, but the states will be fixed. Okay, and it cannot work beyond those states. So that is about interactive English tutor. Yes, students. So today, we again had a quick recap of PEAS. Okay, and if we talk about PEAS, so the various examples we took was about a taxi driving agent, okay, medical diagnosis system, then the part picking robot and the interactive English tutor. And afterwards we had a discussion about the environment in depth, okay. And then we again took various examples of crossword puzzle, then chess with clock, okay, then poker, backgammon, taxi driving agent, then the medical diagnosis, the image analysis, okay, the part picking robot, the interactive English tutor, etc. And hereby we understand that how it is very important to know in which environment they are working, because until and unless it is not clear in which environment they are working, it is very difficult to understand the process of their making. Because moving forward, okay, understanding all these examples and understanding how environment, how actuators, how sensors are important for them, our next process will be actually understanding what is the structure of an agent. Okay, so again, not to a depth of a technical level, yes, but the still, let's say, we can say much more advancements that we have seen now. So till now we only know that agent, yeah, agent works in environment, agent has actuators and sensors, but now we have to understand in detail. Okay, in detail in the sense, okay, how the agent is going to actually work. Okay, so when we say it is going to perceive from the environment and give the action, how it is possible, what exactly it is going to do. Okay, so we will now be going forward to understand that mechanism, wherein we are going to understand the working of the agent. Okay, wherein we are going to understand the structure of the agent, wherein we are going to understand where these percepts that we are talking about, okay, are going to be mapped. So these things are there, okay, which we need to basically identify. And that's why understanding and taking these examples was very important, so that whenever now we go on understanding the agents, we can now relate, okay, that yeah, this would be the environment in which it will be working. And because the environment is, let's say, sequential in nature, we have to train the agent in such a way that it can map the action with respect to the sequence of percepts. Yes, because the environment is dynamic and continuous in nature, we have to make the agent train so that it can learn and give certain actions after the learning process. So all those things will become much more clear when we are well aware about the environment of that agent. So yes, students, that was for today. And yeah, thank you all. Yeah.